So good morning, students. Today we are going to find initial basic feasible solution for transportation problem using least cost method. Find initial solution for the following transportation problem by using least cost method. Here the data is given: origin, destination, the respective cell values is given, demand as well as supply is given. Okay. Solution. First write the given problem as it is. Before proceeding that problem, we have to check whether the given problem is balanced one or not. How to check whether the given problem is balanced one? Sum of the demand and sum of the supply are equal, then we can conclude the given problem is balanced one. See here, the demand is what? 10, 10, 10. When you add up all these values, we are getting it as 30. Likewise, if we add 7, 12, 11, we are getting value as what? 30. So demand and supply are same. Now we have to find initial basic feasible solution for the given problem by using least cost method. In this method, we have to start allocation from where or which cell value contain the least cost. Okay, yes, in our given problem, which cell contains least value? O2 D1. Okay, so this is the least value. So we have to start our allocation from this place. So for this cell, we have to see supply as well as demand. Okay, whichever is minimum, we have to allocate that one. So here demand is minimum with compared to supply. So allocate demand to that cell 10. Then 10 will becomes what? 0. Then supply 12 will becomes what? 2. So here the demand will becomes 0. Therefore we have to strike out the entire column. Okay. Next we have to see the remaining cell values. Out of remaining, we have to see which cell contains the least value. So here 1 contains, 1 is the least value. Okay. For this cell we have to see supply as well as demand. So whichever is minimum, that you have to allocate here. Here demand is minimum, so allocate demand 10. Okay, then the demand will becomes 0, then supply will becomes 1. Okay, so now the demand will becomes 0. Therefore we have to strike out the entire column. Then we have to see the remaining cell values. Out of these, which one is minimum? 2. So for this we have to see supply as well as demand. So for this cell, supply is 2, demand is 10. So obviously supply is minimum than demand. So we have to what? Allocate supply 2. Then supply will becomes 0. Then demand will becomes 8. Demand will becomes 8. Therefore supply will becomes 0 means we have to strike out the respective row. Yes. Then here 2 unallocated cells are there. Out of these, which one is minimum? 5. So for this cell we have to see supply as well as demand. Supply is 1, demand is 8. So we have to allocate the minimum value of supply as well as demand. So minimum value is what? Supply 1. So we have to allocate 1. Then the supply will becomes what? 0. Then the demand will becomes 7. So finally we are having only one cell. For this cell you have to see supply as well as demand. See, both values are same. So now we have to allocate. Then strike out. Supply will becomes 0. Demand will becomes 0. Then we have to cross over the last cell. Okay. So after allocating all these things, we have to find initial basic feasible solution. Yes. For finding initial basic feasible solution, we have to check this condition. M plus n minus 1 equal to number of allocation. Here m represents number of rows and n represents number of columns. So here 3 rows and 3 columns. So 3 plus 3 minus 1 equal to how many allocations we are having? 5 allocations. So 5. So 6 minus 1, 5 is equal to 5. So this gets satisfied. Then we started to write initial basic feasible solution. Initial basic feasible solution is nothing but what? Multiplication of allocation into respective cell values. Okay, therefore 10 into 0 plus 10 into 1 plus 7 into 6 plus 2 into 2 plus 1 into 5. Here we are having that. Now multiply all such things, add, we can get initial basic feasible solution for the given problem. For this problem, 61 is the initial basic feasible solution. Thank you.